Lewis structures or Lewis dot structure are just a representation of valence electron in an atom, ionic compound, and molecular compounds by using dots and sticks. Now, I want to focus here in particular the ionic compound. Well, let's begin with the review of what an ionic compound is. Ionic compound is made up of a metal and a nonmetal. Not only are they made up of those two, but they are made up of a cation from a metal side and an anion on the nonmetal side, meaning cation is a positively charged metal and a nonmetal of a negatively charged nonmetal will combine together to form an ionic compound. In between, the bond between the two is considered to be an ionic bond. Let me show you an image of an ionic compound that has applied the Lewis structure. So here are two ionic compounds. First one is lithium fluoride, and the second one is calcium chloride. We are used to seeing the nomenclature or the molecular compound looking like this, LiF, and calcium chloride to look like this. This would be their chemical formula. But over here, what this is showing you is the Lewis structure of the lithium fluoride, Lewis structure for the calcium chloride. Fluorine is filled with 8 electrons. It had the lithium, which had one, has donated to fluorine. Here's calcium. It's void of any of the valence electron, but you see the chlorine having all 8 valence electron. Well, how did this come about? Well, it came about with lithium originally when it's neutral had a valence electron of 1. Lithium is on the very first row of the periodic table. Fluorine is on the 7th row, and so you see 1, 2, 3, 4, 5, 6, 7 valence electron. And well, what happened there? One of the electron from the lithium has donated its electron to the fluorine, and it went here in that position. Well, when it went into that position, it became lithium fluoride, lithium gaining a positive charge and fluorine a negative charge because fluorine has gained 1 electron and lithium has lost 1. Where did it lose it from? It lost it from the valence electron. This represents valence electron, so this is void of it. For fluorine, it has gained an electron on its very outermost level. It already had 7, now it's going to have 8, which is highly favorable since it fulfills the octet. Let's look at calcium and this chlorine, for example. So in the beginning, before it formed into an ionic compound, calcium by itself in neutrality has 2 valence electrons, chlorine's 7. I see you should see that there are 2 chlorine. That's because one of the electron gets donated to this area and the other one gets donated to the other chlorine. So you see that the chlorine sort of stripped away all of the electron from calcium, and each of the electron went from the calcium went to chlorine. To kind of summarize this whole thing, you could see that the left side of this equation, chemical equation, these are showing just the formation of the ionic compound. Individually in itself is the Lewis dot structure of the atom. Now on the very right side, these are the ionic compound Lewis dot structure. So when I'm talking about can you find the Lewis dot structure for ionic compound, I am looking for what's on the right. But if you're trying to draw how is the ionic compound formed from the atom in itself, then I'm looking for the left, and you should draw this process going to the right. Let me give you a book definition. Remember that the ionic bonds are formed when there is a transfer of electrons. So there's a transfer of electron and forming into a cation. These are the cation and the anion. And they're able to stay together because of the electrostatic force the opposite charge attract. Lastly, the Lewis dot structure are just the visualization. You can see how ionic bonds are formed in this case. Let's do a learning check that applies all of what we have learned. Use Lewis dot symbols to show the formation of potassium oxide. So it's already giving you the hint of K2. So it should be involvement of 2 potassium and 1 oxygen. Check valence electron and draw symbols for 2K and 1 oxygen to start. Use arrows to show what is losing electron and what is gaining electron. So let's try this, and the next one you can try it on your own. So potassium K in its neutral format has 1 valence electron, and we need to draw 2 of them. And then 1 oxygen. Oxygen has valence electron of 6. 2, 3, 4, 5, 6. Now the potassium is going to donate, since it's the metal guy, they're the one that's going to donate it to the non-metal. Okay, that leaves oxygen 7, and this one is actually going to get donated to the other side of the oxygen. Now the potassium will have just positive charges, and oxygen will have all of the outermost shell filled with the -2 charge, since it gained 2 electrons. So here is how the Lewis dot symbol is showing the formation of potassium oxide. You try for the formation of aluminum oxide on the second one, and then come back and check the key. And here is the key.